Welcome
to the joy of coding.
Hello, and welcome to episode 343 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. It's 343, right? Yes, it's 343. We're going to be live hacking on some Firefox stuff today. We're getting back to the Windows jump list stuff. I'm very excited about that because, we took a week off last week to work on something else, and now we're getting back to the jump list stuff. We might even get these patches ready for review, and this could be it, gang. Place your bets now. Let's see how it goes. Let's start by me sharing my screen. So this is today's agenda. Yeah, it's October 18th, 2023, episode 343. A reminder, no plan survives breakfast. I think I know what's going to go on today, but I wasn't joking when I said, place your bets, because who knows what'll happen. Who knows whether or not the jump list stuff will be put up for review. Maybe it won't. Maybe it'll all go sideways. Maybe we'll find a serious bug and we'll have to start fixing it, and maybe we'll get stuck on that back. Who knows? Who knows? That's all part of this. We're just going to figure it out together. Like I say every episode almost. I think I've been saying this for years. It's software development in the raw. If there was a slogan for or like a tagline, if this was a film, if The Joy of Coding was a film, the poster would be me going into the camera, and it would say software development in the raw, no plan survives breakfast. Software development in the raw would probably be the tagline. And the critics' reviews would be like, why was this screened at Cannes? Why was this screened at TIFF? And I'd be like, I took over the projector room. Anyways, let's see. What do I want to talk about today? Well, I was hoping we could... I wanted to give an update on something we'd worked on last week, which was that we were making an effort to get something wrapped up for Firefox 120, which was a patch to make it possible to import from other browsers when Firefox is installed as a snap package on Ubuntu, which is... But these days, that is the default way of installing Firefox on Ubuntu Linux, is you use the snap package. You go to the Ubuntu, I think it's called like the App Store or the App Manager or something, and you install Firefox. That is a snap package that you install, which is specially sandboxed, and that sandboxing prevented us from being able to kind of reach out and import data from other browsers, even when the user has expressed that is something that they want to do. So we were able to find a way of offering that capability to people, so that if they're migrating from another browser into Firefox, it's possible now. That patch has landed. It's in nightly, and QA is testing it, but so far things seem to be going well. It seems to work. So fingers crossed that's going to ship in Firefox 120. So if you're on Ubuntu and you have been waiting to be able to import stuff from Chromium, at least, this Firefox 120 should allow you to do that if all goes well. And then we're going to add the other kinds of browsers as well eventually. I think there are snap packages for Brave and Opera. Those are the two big ones. I don't think any of the other, Chrome isn't offered as a snap package, interestingly. Chromium is, but Chrome is not. And Edge is not. And Vivaldi is not. Opera GX is not. It's just Brave and Opera. Those are the ones I know about anyways. I'll have to take a look again. The package store has lots of stuff in it, and basically I just used the search query browser. So I'll have to do a little bit more homework there. Anyway, I just wanted to update you on that. If you wanted to see what the patch looks like, what ultimately landed, you can check out the bug. Okay, it's Windows jump list time. Smurfy, so Craig says, which actor would play Mike in a film about the joy of coding? And Smurfy says, Seth MacFarlane. That's a high praise, high compliment. Apparently my celebrity lookalike, and you as the crowd can, if you're watching this, you can comment and see if you agree. But I've heard from multiple people that I look like John Hannah, who's an actor. I think he's Scottish, a Scottish actor, John Hannah. Maybe he's a little older, but that kind of looks like me. I think this looks like me whenever my hair's grown out. And who's the other person that I sometimes am told I look like? Oh, when I was in school, apparently I looked like the lead singer of Hoobastank. This is what I apparently looked like, was this guy. That was me in school. So there you go. Let's move on. Right. So what we had started doing the episode before last is we were going through the stack of patches. We were cleaning them up, looking for to-dos or things that we forgot to deal with, and trying to just kind of knock them out. I have recently rebased the patches, and I ran the tests. They're all passing still. That's good. They build, they still pass. That's all great. So let me now, that I've rebased these patches, let me push them up for into Fabricator again. I'm going to do mozfab submit. Actually, before I do that, mock lint outgoing fix. We're going to run the linting. We'll absorb any changes, and then we will push these up to Fabricator, and then we will work through the last two patches, which I think they're both much smaller than the ones we were looking at last time. Yeah, this is one patch, which is like this big ol' the front endy bits to wire up the new back end, and then finally our last patch to look at is the test that we've been spending a lot of time working on. So that'll be fun. All right, come on, linting. Linting is interesting because it's not just JS linting, it's C++ linting. It's running a bunch of different linters depending on all the files that change, and it has to go and get like the latest and greatest rules and apply them. And it looks like there was one error. Oh yeah, it always has this problem where Firefox.js is not. It's got .js because it sounds like it's a JavaScript file, but it's actually not really. It's just the prefs list, and so it's concerned about that, but that's fine. Okay, so let's post these up to Fabricator. Submit whip. And so my colleague Andy Kokendorfer, who is apparently watching the stream right now, says that he input software development in the raw, no plan survives breakfast, Mozilla, the joy of coding, my colony Toronto, into Midjourney, which is a what's going on here? Oh, I gotta install mozfab. He's put those terms into a tool to generate like a generative AI tool, and I want to show you the image. How do I do this without showing you all of the stuff? Hold on. Yeah, okay. This is apparently what came out the other side. This is, again, the terms were software development in the raw, no plan survives breakfast, Mozilla, the joy of coding, Mike Conley, Toronto. So let's see what we have here. I guess that's supposed to be me. The fingers, Midjourney always having problems with fingers. That's a classic. I like pancakes. This is very seasonal because this kind of looks like a pumpkin. It might also be maple syrup. This candle could also be a mug. I don't know what's happening. This is very like interesting. Where like yeah, I'm eating pancakes and a candlelight pancake breakfast, I guess. And this looks like dream letters. Ehau se Galnil Bauvui Ravnesta Sivas Oud Meek Bavils Dok Kokub Bappy. Okay, so I'm gonna stop reading that. This is interesting. This is also what got spat out. I think I've been in this restaurant before. What I'm looking at here. This looks like a real restaurant. It looks like a place I've been to in Toronto. This looks like a AI generated Will Wheaton. I don't recognize where, like, I guess this is maybe the joy of coding. This might be a location in Toronto. That's interesting. This mug is dangerously close to the edge of the table. That stresses me out. Down here, this is very interesting. This fox looks like he's up to no good, blue hair like Sonic the Hedgehog. And Return of Dolomite asks, am I simultaneously streaming elsewhere? Yes, I'm simultaneously streaming to Twitch, Diode.zone, YouTube, and Air Mozilla. I'm multicasting. It looks like this fox is like planning evil things in a Sonic bodysuit. It's got like protective goggles on. Looks like they're in their living room eating like just the stack of tarts. Like there's some evil plan here related to this stack of tarts. That's very, very interesting. I've felt like this person before. This looks like art from Gorillaz, like the band Gorillaz. This is pretty neat. Again, having problems with the fingers, although maybe the thumb and index are hidden behind these three. It looks like this phone got broken. Like I just got frustrated, threw my phone, and all the pieces broke. Wow. This is very neat. Very neat. Thank you, Andy Kokendorfer, for the artwork. Outstanding. All right. So let's review these patches. Oh, come on. What's? Did I? Oh, sorry. I'm in the wrong window. So that's done. I'm gonna submit whip, and that stuff's gonna go. We're gonna submit that stuff as a work in progress. And then we can start taking a look at this patch. We can actually start looking at this patch right now. So this is going to be, I think, a significant chunk of this episode is looking at these patches and comparing it to our to-do list. I'm pretty sure our to-do list down here. That's an interesting question. That seems like a to-do. This seems like an interesting question. This is interesting. And then this is new separate work. Okay. So, what we are adding here is a new preference to enable or disable the legacy backend. It's enabled by default. And it looks like there's some code that pre-exists that's reading this branch. We call these individual like period separated terms. They're like preference branches, and so we're reading off of presumably the browser.taskbar.lists branch, and some part of the code is like, okay, now read this part of that branch. What are we doing here? We're adding a state variable, is building, defaulted to false. Adding a comment here. Constructs the tasks and recent history items to display in the jump list, and then sends those lists to the NSI jump list builder to be written. Returns a promise. The promise resolves once the jump list has been written, and AI items that the user removes from the recent history list have been removed from places. It's also this. Oh, I see. This is in a try finally. In theory, this could throw. This could reject. So that's worth mentioning. Did this get? It's still MozFab. Let's go. So that could throw. You know what I'll do is I'll start up Sublime. No, Windows. That's not what I wanted. Just close. Sublime. No, Edge, get out of my way. Look, I don't know if anyone else is experiencing this behavior from Windows lately. It is outrageous. Someone has an OKR that they have to hit, and someone is trying to bump their numbers because they are just hammering me, pestering me for, hey, Edge, hey. It's infuriating. Okay, so the file is Windows jump lists, and it was populate. Was that the name? Build list. That's the name. Build list. What? Do I not have the patches checked out? don't know why. Maybe it's because MozFab is like in the middle of working, but like, where's the changes? Where are the changes? Let's wait for MozFab to finish. I don't know if you noticed, but it was just sitting there, and then I smacked my enter key a few times. This can happen if I've accidentally like selected a character in the terminal. It'll just like block all execution if I've selected a character until I press like the enter key. So if anything ever seems frozen to me, one of the first things I'll do is I'll just like hammer the enter key in case the Ming W32 shell is like blocking the execution. I don't experience that in any other shell environment. Okay, so there we go. We had to reach that part of the process. Constructs the tasks. It's going to return a promise, undefined. This might reject. The promise rate may reject if any part of constructing the tasks or sending them to the builder thread failed. That's correct, right? Like if we go back to our NSI jump list builder, populate jump list, we made this clear. It potentially throws, and then we should say promise may reject if any part of constructing the tasks or sending them to the builder thread failed. And that yeah, yep, that works for me. I mean, I don't think there's much we can do in the event that there's an error. Like, I think we just call it and we just hope. Oh, that's interesting. We'd commented this out. We're going to have to put that back. Okay, so we did that. We checked to make sure that our builder is an instance of NSI jump list builder. Okay, that's some belt and suspenders right there. Make sure that we're not accidentally entering this when we're using the legacy jump list builder, I guess. And then we see if we are not enabled or we're disabled, and if we are, then we will just delete the active jump list. Are we in the midst of building an earlier iteration of this list? If so, bail out. Same if we're shutting down. If we're building or shutting down, get out of here. Okay, then we say we're building. And then we check for removals. We ask the jump list, hey, what are any URLs that the user has removed from the jump list? And if we have any, then we'll clear them from history. Then we'll construct our tasks. And we'll construct our history if it's enabled. We'll go and do a query. We'll get our custom descriptions. Why we're here, Todo Document. Okay. Document why we're catching exceptions silently here, and maybe be a bit more choosy about what exceptions we eat silently. Okay, so obtain and cache favicon. That is interesting. I'm now remembering this. It will throw NS error not available if the favicon has never been cached to disk before. So that's the one that we want to. This is what we want to mention. Obtain and cache favicon may throw such and such if the icon doesn't yet exist on the disk, and but has been requested. That's not fatal, so we'll just let it pass. Any other errors, however, will bubble, will abort on. If e dot, let's see, where have I seen this done? cr.ns error. If x dot result, if e dot result equals not equals to cr.ns error not available, then throw E. Then we'll construct this thing. And then we get our custom title, which is using getString, which still using string bundles. This seems ripe for conversion to Fluent, but that's something for a later time, I think. And then if we're not shutting down, then we'll say, okay, populate the jump list. Because we have to keep kind of checking that, because we do all these like async things, and so we might begin shutting down at some point while we're waiting for like the database requests to come back. In which case, yeah, if we get here and we notice that we're shutting down, then we'll just like bail out. Otherwise, we will populate the jump list. That looks good. That looks good. This is the legacy one. We've renamed it. We make sure that we're using the legacy jump list builder. In the event, we'll just here we have this shared method delete active jump list, and in the event that we're using the modern one, we'll call it clear jump list. Otherwise, we'll use delete active list. Then we will return. We'll make it so that clear history returns a promise. I'm gonna update actually. Let's update the documentation there. So get some inline documentation. Removes URLs from the places history. History in places that the user has requested to clear from their jump list. We must do this before recomputing which history to put into the jump list, because if we ever include items that have recently been removed, Windows will not allow us to proceed. And I think there is a comment or a link that I can point them to. See such and such. See such and such for more details. Okay, and then the parameters are, it's a string. It's an array of strings. URI specs to remove. The URLs to be removed from places history. And it returns a promise that resolves to undefined. It looks like yeah, this the returned promise never rejects but may report console errors in the event of removal failure. Okay. All right. That's done. And then here we've got like a use legacy backend thing. We'll go and get the pref. We do a one-time start read of the backend pref here because we don't want to consider any bugs that occur if the pref is flipped at runtime. We want the pref flip to only take effect on restart. So, exit if this isn't Win 7 or higher. I guess we need this before init taskbar. That's why. On update, if we're shutting down, then we don't do anything. If we're using the legacy backend, we do this stuff. Otherwise, what is built PB? Okay, this is a thing we've got to figure out. This was some change to clear in documentation. Oh, did I declare. Did I? Yes, you're right. Thank you, Smurf D. Windows command.exe was not really meant to be used. Yeah, true that. All right. Let's see. Let's keep going. So PB Builder, build list legacy. What? First of all, what's built PB used for? I think that's important to know. Built PB. If we haven't done this before, then we'll build it once. We only do this once, but we do it here to avoid main thread IO. We only need to do this once. We only do it once? We don't update it. Okay. All right. Well, if that's how you want it to work, if not this dot built PB, if that's how it worked before, this dot built PB equals true. But we only need to do this once, but we do it here to avoid main thread IO and startup. When did this get added? We only need to do this once. When was this done? Ben, here's some. Browsing. Create a separate jump list for the private browsing taskbar icon. Only need to do this once. We only build the private. That seems like it's a. Yeah, that is a like intentional design decision. We intentionally ever do this once. Ever need to do this once. We never want to, we do not want to, the private browsing jump lists over time. But why? Yes, that's a question for Molly and Ben, who might end up being my reviewers here. Okay, and then init the taskbar. We have our two builders here. We check to see what kind of backend we're using. So builder, create legacy, create jump list builders. The false or true is whether or not it's a private browsing context. If it fails, return false. We check to make sure it's available. We'll return false. We make this an async function. And that's in init taskbar. During startup, we make this async as well. It sounds like some tests got created. Create a separate jump list. What kind of tests did Ben create? Use a unique icon. Tests. Update jump list builder tests. Whoops. Oh, these things. Create jump list builder. Okay, that's fine. Okay, let's build this. And let's see what it does. I just did a Clobber build, so we're going to have to start by enabling the new backend, disabling the legacy backend, basically. Spamming enter. Nothing. What's going on here? Mock build faster. But otherwise, that patch made quite a bit of sense to me. I mean, I didn't see anything super wrong with it. I'm glad we caught the PB thing, PB builder. We're going to have to test that now. I'm planning on testing that next once this build job finishes. Okay, while we're waiting on that, let's take a look at the other patch. What does a Clobber Build mean? Great question. So normally whenever we do a build, if you've got a pre-existing build, we don't rebuild everything. Like we don't recompile every C++ file to an object file. We don't recompile every Rust file to an object file. Like, so that there are two steps to a compilation, generally speaking. I'm oversimplifying, but there's like compile to an object file, and then you link all those object files together into a binary. Sometimes that binary is a library, sometimes it's an executable, sometimes it's a mixture, sometimes you're linking a bunch of things. What we would call an incremental build is whenever you change a small part of the source code and you run mock build, we will just rebuild the object files that needed to update because of the change source. Like we'll check to see which files got touched, we'll rebuild the object files, and then we'll relink everything, but we'll keep all the old .object files that had previously been compiled around, and then we'll relink things. And that's a lot faster. Like you don't have to recompile a bunch of stuff. It's just the stuff that changed. That usually works, but there are times, it doesn't happen too often, but there are times when it is necessary to blow away all of the object files and rebuild from scratch. That's called a Clobber Build. And when you do a Clobber Build, it also blows away like the temporary testing profile that is used whenever you use mock run. I hope that answers your question, Makuba. Great question. Okay, so here's our Windows. I'm going to go to About Config. We're going to say Legacy Backend. It's on. I'm going to disable it. We're going to shut down, and we're going to restart. Okay, so let's see here. So we've populated things properly. Let us now open up a private browsing window and check to see what it has. So it has its own things. Oh, the reason why we only ever need to do it once, we don't put history in it. Just these tasks. That makes a lot of sense. That makes a lot of sense. In fact, let's ensure that that's true. PB Builder. When we build list, hang on, a builder build list, we'll check to see, we won't add the history if show frequent is disabled. And I believe that is something that is it controlled via prefs? Refresh prefs. Prefs. PB builder refresh. Oh, show task is only relevant for. Okay, so we force the PB builder to not have recent history items show up in it. Okay, that's why. Built PB. So we can now say we only ever need to do this once because for because the jump list, the private browsing window jump list only ever shows the static task list, which never changes. So it doesn't need to be updated over time. Great. I'm glad we solved that mystery. Okay, I feel pretty good about that. And I'm glad this is working so well. It works really well. This is updated. Yeah, great stuff. Great stuff. Okay, Next step, our tests. Okay. Um, let's look at the small file first. Very easy. We're just adding our test to the build that runs whenever we're constructing our G tests. That's great. All right, now let's look at our test. So there's a bunch of stuff we have to bring in, apparently. There's some things that are missing. Prop variant to string is apparently something that we have to like declare ourselves. This is very bizarre. We had to do all this. We bring in the G-test and G-mock. We bring in our bindings. We say, hey, we're using these things. I should document what this constant is for. So let's do that. Test. What? Where did it go? Test. Jump list builder. Here we go. K wait timeout. We only use it in one place. K, this is the amount of time that we will wait for the background thread to respond before I mean, does it need to be like global for the entire file? It's just used in one place. You know what? What I'm going to do is I'm going to move this actually closer to where it's used in context because it's not shared. Amount of time that we will wait for the background thread to respond before considering it a timeout failure. Great. And this can be unsigned. Can it just be, I guess, let's not change the types on it. Let's go back to the top. So we've got our matchers. Let's document these. Matches, gmock matcher that ensures that a LPCW stir that two LPCW stirs match. Gmock matcher that ensures that a shell links, what is it? Shell links equals desks arg. Oh, it's a what is it? It's a arg is a what? Task desks, which are an NST shortcut description, but like that's the second argument. The first argument is whatever is passed to add user tasks, and add user tasks is passed an iObject array. Okay, iObject array pointer. Gmock matcher that ensures that a iObject array pointer contains NSI shell link W's that match an equivalent set of NST array Windows jump list shortcut descriptions. Okay. All right. That's done. To do. Okay, so we're going to describe this thing. This is a helper class that allows our tests to wait for a native promise, a native DOM promise to resolve. And get the value that the promise resolves with. Get the JS value. This is probably the most useful stuff. Blocks the main thread, blocks the current thread. I think this is, we should make it clear, like, this is expected to run on the main thread. Blocks the main thread, blocks the thread, I'll just say. It doesn't block it, spins a nested event loop and blocks until the promise has resolved. Spins a nested event loop and blocks until the promise has resolved, after which the JS value that the promise resolves with is returned via the aretval out param. So param JS mutable handle JS value aretval the out param for the JS value that the promise resolves with. Returns void. Okay. To do. Testing jump list backend. An implementation of jump list backend that uses the gmock framework, that is instrumented using the gmock framework to capture calls, to record calls. Unlike the native jump list backend, this backend is expected to be instantiated on the main thread and passed as an argument to the jump list builder's worker thread. Caller, this class does the work. Callers should ensure, let's see, should wait for promises to resolve for the tested functions. Promises. Callers. Testers should wait for the promise, the methods that call these functions to resolve their promises before checking the recorded values. Okay, is available. Get monitor. In one case, when do we get monitor? When do we do this? when we test construction. In one case, construction, an operation occurs off of the main thread that we must wait for without an associated promise. Testers can use mmonitor to wait for such things. Maybe that's superfluous. Okay. To-do document. Generate Windows shortcut description. A helper function that creates some fake Windows jump list shortcut description objects, as well as JS value representations of those objects. These are returned to the caller through out params. Param, JS context, a CX, the current JS context, the execution environment, current JS context in the execution environment, param uint32t, how many, the number of Windows jump list shortcut descriptions to generate, param st array. Here, I'll just copy this. Array, the out param for the array of Windows jump list shortcut, array of generated Windows shortcut descriptions, and then similarly param a JS val array, the out param for the array of JS values representing the generated Windows jump list shortcut descriptions. Okay. And then to-do document, why we need the monitor, because construction, okay. We do construction of our class, or any class of that matter, does not return a promise that we can wait on to ensure that the background thread got the right information. We therefore use a monitor on the testing backend as well as an expect call to resolve to block execution of the test until the background work has completed. Okay. Prepare us to return 2 entry collection of iShell links. Okay. This is all good. What did we do here? We We create our testing jump list backend. I'm wondering if we should make these all strict mocks. I think I have a note about that. Consider making them all strict. I don't know why they'd all need. We'd want them to be nice. How many are there? 4. There are 10 strict mocks. All right. Let's see what happens if we replace every nice mock with a strict mock. Let's build and find out. Where is it? There we go. Okay, while we're waiting for that to run, let's keep going. I guess I stopped looking at it in Fabricator and I started looking in here, and that's okay. This is the test I was interested in looking at next. And a warning. The variable HR is set but not used. I'd love if we can get rid of that warning. Because I do check it. I do check it here. Do we have examples of us suppressing that sort of thing in G-tests? H result, HR. H result. Not really. I think we're really breaking new ground here. Is H result success? Is this something I could use? Is H result success? G-test internal. G-test. Maybe I could use this. Assertion result. Actually, I think part of the problem is that this is all occurring inside of a will once. So we can't actually use that. That's the problem. Yeah, that's the problem. Ooh, this failed. After we made for strict. Uninteresting mock function call returning default value. Function call set app ID. Uninteresting mock return default value. Abort list and abort list. This is in check for removals. In here. And I'm saying, hey, I expect a call on such and such. What do we do elsewhere? Strict mock. This stuff. This is what I expect to do. So it's like you called abort list twice and set app ID. Okay, that abort list twice is interesting. So why would we call abort list twice? I think that sounds familiar. But let's take a look. Jump list builder, where are you? and check for removals. You do check for removals. We call abort list right from the very top. Abort any ongoing list builds that have not been committed, and then we do it again just in case. We should mention why. We began a list in order to get the removals, which we can now abort. Okay. So yeah, we do expect this twice. Okay. So if that works out, then I think we can check off our making everything strict mocks. Unused but set. Is there a way I can like... media. Okay, that all worked. Great. Next up, yeah, how did this work? We were making sure that our app ID was set properly. Let's prepare a begin list return a 2-entry collection of iShell links. The first iShell link will have the URL be example.com. The second will have the URL be mozilla.org. So we create instances of a collection and a shell link. And let's reuse the same iShell link, but change the URL to add our second entry. The values of the iShell link are ultimately copied over to the items being added to the collection. Okay. And then we check for removals. We wait for it to resolve. Make sure that the returned object is an array. We should expect to see 2 URL strings returned in the array. The first one should be example.com. Second one should be mozilla.org. Yeah. Okay. Test calling pilot junkets with empty arguments. We should call the following methods on the backend in order. I think this is the sort of the format. It should call test calling and receiving a series of jump list entries, calling check for removals should call the following methods on the back end in order. And then it's set app ID, abort list, begin list, abort list. We should add this to the top of every single one of these. Set app ID, abort list, begin list, commit list, and then it never calls delete list. Okay, so yeah, that's what we do. Test calling populate jump list with empty arguments, which should call the following methods on the back end in order. This should result in an empty jump list for the user. So we call it with nothing. And then test calling populate jump list with only tasks and no custom items. This should call the following methods on the back end in order. This should result in just tasks shown to the user, no custom section. Excuse me. We generate 2 tasks, no custom title. And we populate the jump list. We wait for the promise to resolve. Test calling populate jump list with only custom items, no tasks. Call the following methods on the back end in order with just custom items. We have our custom title and our custom descriptions here. App ID, abort, begin, no user tasks. We expect append category to be called, and then commit list and delete list. That's great. A test calling populate jump list, tasks and customize. This should call the following methods on the back end in order. Generates 2 tasks, 2 customs, and a custom title. Yes. Append. Yes. Add user tasks. Shell links equal. Yes. 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 Populate the jump list. Yes. Test calling clear jump list. Calls the following delete list, passing the AUM ID. This results in an empty jump list for the user. Yeah, that's great. I'm really happy with that. All right. Let us absorb these and post it for review. Absorb. Maybe I'll ask Molly and Ben here some to review both of these. This comment, I guess what I'll do is I'll go prev, amend, and then next. Gang, this is a milestone moment. We're posting the patches for review. I'm doing a happy dance. I'm doing a happy dance. Now, that's not to say that people will not find problems with them. Molly and or Ben might decide that my patches have serious issues, and then we have to like make changes. That's possible. So temper your expectations. But I'm gonna update the commit messages to also add Ben. All right. All right, everyone. We're doing it. We're doing it. Moz, Fab, submit, no whip. You seeing this? Here, I'm gonna. Well, let's get a sound effect queued up. Start level. What else? What was good stuff?
Here we go!
Ah, doesn't know what I mean. No whip. Moz, Fab, submit, help, whip. Okay, so if I don't supply it, So I guess they got rid of the no whip argument. Okay. Mozfab submit. Mozfab submit. Yeah, here we go. Come on. Come on. Come on. Come on, Mozfab. Don't break my heart. Oh, what are you doing, Fabricator? Come on. You're killing me. This is supposed to be a big moment. All right, fine. We'll have that run in the background. Hooray! So we're submitting that. I'm pounding like the enter key again just to see if it works. Let's pretend that worked properly. Woo! Congratulations! We finally. This is a milestone moment. If you've been sticking with me from the very beginning of thinking about the jump list stuff to now, we did it. Congratulations. Let's take a look at our to-do list. See if there's more that can be done. Do I really need to convert each Windows jump list shortcut description JS val into a rooted JS val before initting to the structure? That is something maybe we could try and answer now. I'm not going to try and deduplicate the tests unless the reviewers think we need to. Not right now. And then NS main thread pointer holder promise holders on jump list builder? That's a legitimate question. Okay. Oh! There's like a... Oh, what's happening here? Change is detected, right, because of the mercurial stuff. I don't know what Fabricator is doing, but I can't really touch things until Fabricator is done, or Mozfab is done. So we're going to look at something else while we wait for this. We're going to... Oh, here we go. It's submitting diffs and stuff. Great. Well, while that's doing that, we're going to... Excuse me. We're going to submit a patch for something else. We're going to see if we can help out with this ESMification project because there's some new tab stuff that is blocking it. And I happen to have been looking at some new tab code lately. And while I'm here, I'm thinking I might help with the ESMification effort. If you're not familiar with the ESMification effort, we're trying to migrate all of our what used to be called JSMs. These are like Mozilla-specific JavaScript module format to ECMAScript standard modules. Because then we don't have to maintain a special thing. And if you're curious about all of the details on what I'm talking about, this chart is public. You can check it out. I'm going to post a link. Put it right at the top here, actually. Boop. And you can read the migration document to understand why we're doing this, if you're at all curious. Okay, that's done. Okay, good. What I wanted to do, I'm taking my attention back now to jump list. What I want to do is we're on the to-do list. It's like, do I really need to convert each Windows jump list shortcut description JS val into a rooted JS val before knitting to the structure? And that is something that occurs inside of jump list builder rooted here. These two things. Do I actually need to do this? Because DOM to JS value, what does it take as the third argument? It's just a mutable handle. It needs a handle. And maybe rooted is okay. What is a JS rooted? JS rooted. What a mutable handle. Is this what I want instead? Like whenever someone passes something to like Chrome utils, let's see. Get initial process data. Who calls that? Get initial process data. Okay, so it's a rooted. Maybe that's fine. Okay, it's probably fine. Other people are doing it. Apparently, I just need a JS mutable handle, but at least one example. This one shows this being how it is, so why not? Okay. And then, do I want NS main thread pointer holder promise holders on jump list builder? What is a, whoops, what is an NS main thread pointer holder? It's a promise holder. So if you got something on the main thread, you create a promise holder and you use that to move your promises around. And then you get, I guess that's a way you can avoid it accidentally getting destroyed before the background thread deals with it. That might be a good idea. That might be a good idea. Let's see here. Let's start with so all of the things that return promises. That's is available. We'll start with is available. So it's a runnable. A promise. You create a promise. Maybe this is like a more like a less verbose way of doing this. Maybe this is better. Error result RV ref pointer DOM promise. I'll just say ref pointer promise create DOM promise. We can just say promise create XPC current native global CX RV if Moz unlikely. Yeah, okay, let's do that. I think that's maybe less verbose. And then the other thing we need to do is need to set up our promise holder. Main thread pointer holder promise create jump list builder is available promise. And then this new runnable method. Instead of store copy pass by reference, can I just do promise holder new runnable method promise. New runnable method. Promise. ID. That's the way it used to be done. And what was the example we were looking at? As main thread pointer holder. New runnable method. Promise holder standard move. I wonder if we could like do is available. How? Like we could kind of combine some of this stuff. Let's see. Let's just see. Is available. So instead of having a separate method, we could do what this is doing, which is dispatch new runnable function. A new runnable function returns an NSI runnable. Okay. Runnable equals new runnable function is available. And then the things that we pass are, do we need to pass this? Let's find more examples of a NS main thread pointer holder for a promise. Oof, what? Bad gateway, uh-oh. Oh no, search fox. Okay, NS edge migrate, let's NS edge migration utils. Main thread pointer holder promise function standard. Okay, not quite, not quite. Fetch driver, DOM fetch driver. Main thread pointer holder handle, and then new runnable function. There's okay, it's working again. Window handle. Telemetry. Here we go. Main thread promise. Runnable. New runnable function. Do I need this? Do is available. I kind of need this in order to get at the back end. ref pointer this self equal. Oh, here we go. Function self ref pointer this. Okay. Is available. Maybe we'll. I like this. Func. Whoops. I can spell. Func. Self equals ref pointer this. And then we also need the promise. So the example that we saw was standard move promise holder equals standard move promise holder. New runnable function, and then you got your square brackets. That's done. And then this, you put your function in, and then that becomes your runnable, and then you dispatch your runnable here. So, and then on the receiving side, your function gets a promise holder. Okay. I don't know if this is better. I actually don't think this is better. But maybe it's the right way of doing it. Because like this main thread pointer holder, I think is keeping the promise alive. Well, we have a ref pointer here. What is the definition? What is this thing? What is this thing? Let's read what this thing is. nsproxy release.h. Main thread pointer holder. Okay. Class to safely handle main thread only pointers off the main thread. Classes like XP, wrapped, JS, or main thread only strings that is forbidden to call methods on instances of the class off the main thread for various reasons. This restriction applies to addref release as well. This presents a problem for consumers that wish to hold a callback alive on non-main thread code. Dispatches new runnables to the main thread in order to execute the callback. This involves several addref and release calls in the other thread, which is forbidden. The basic idea of this class to introduce a layer of indirection is a thread-safe reference count class that internally maintains one strong reference to the main thread only object. It must be instantiated on the main thread. I see. I see. Okay. Well, you know what? Instead of let's back up for a second here. Instead of changing everything to be like new runnable functions, I think we can keep this main thread pointer holder. It's just we're gonna change the we're gonna keep that there. Promise jumpless builder is available promise. And what we're gonna do is we're going to pass pointer holder promise standard move. So we're going to move it as new. Can I say new runnable method? Yeah. New runnable method. What is this used for? Ref pointer promise. Because it's expecting that do is available is going to get a promise and then pass it back. We're going to move it back. I think what we need to do is we need to change the signature to be not a promise, but a promise holder. Service promise holder. Okay, well, maybe the compiler will help us in explaining. But basically what I want to do now is ns runnable method standard move. I guess these are the return values. Store, copy, pass, by pointer. Let's promise holder. This looks relevant. Moz promise holder found in such and such. M holder. What is M holder? Standard move A holder, which is a Moz promise holder, which is a promise type Moz promise holder. Promises type Moz promise holder base. What is the Moz promise holder base? Is very special class to encapsulate a promise for a particular role. But this is for a Moz promise, not a DOM promise. So that's no good. Okay. New runnable method. What am I doing? Can I just... know what the other side thinks of this thing. Function self. What is it? Main thread pointer holder. Oh, yeah. Visited handle callback. We call visited key. Okay, so what does it think it is? It's a main thread pointer handle. Callback, which is it wraps a pointer holder. Okay, so promise what this needs to be is I need to say, hey, you're getting back a ref pointer Moz thread pointer holder, and then standard move promise holder. And then if I do is available, then this becomes ref pointer and this main thread pointer holder. Oh, I've already forgotten. It is available. What is the signature? It is a ref pointer. This thing. Okay. Do is available. We're going to say that you're going to get that a promise holder. And then we'll assert this. Jumpless backend, dispatch to main thread. We'll say a promise holder. Promise equals standard move, a promise holder. Dispatch that to the main thread. Over here, same idea. Standard move, promise holder. And then what we do is inside of the example we were looking at is you get at the promise via promise holder get. That's bizarre. Sir, is that the state of the art here? I guess so. Okay. Promise holder. Promise equals promise holder get. Will this compile? If it does, then what I'm not gonna spend time wasting. I don't want to. Oh, geez, what do I want to do? We've already posted it for review, so that's good. What I might do if this works is I'm just gonna update the rest of these callers to use this format, and not necessarily capture it on the stream, because I think but then I'd be ruining the invariant. I'd be making it so that you didn't see that part. Oh boy, because I don't want to waste your time. Okay, it's 2:35. Let's see here. Let's see if this builds. And if it does, then we'll just quickly change everything. We'll quickly change it all. And the stream might go a little long. Oh boy, we're having to rebuild everything. Is that the case? Get out of here. Don't tell me I have to rebuild everything. Why would I need to do that? All right, well, I'm going to give it 20 more seconds to see if this is going to be a fast build. And if it's not, I'm going to end the stream here and I'm not going to touch it. And then next week we can see if we can convert all these things to using main thread pointer holder. The patches are up for review, so the real substantive stuff is already up, and Molly and Ben can look at it and give me some feedback, and then we can kind of fold that in. So yeah, let's see how this goes. Thanks so much. We did it. Thank you so much for watching episode 343 of The Joy of Coding. Let me know what you thought. There's a link at the bottom of the agenda to rate this episode. I'm actually going to drop that into the chat as well. The link to rate this episode, it's going into the chat. You can let me know. Fill it in. I read everything that comes in. This is a great place to let me know what I can do to make the stream better for you, more interesting. And if you've got questions, I can try and answer them on the stream. You can send them in that way. Questions about Firefox, the code base, or C++, or JavaScript, or anything. I'll do my best to try and answer them. And we'll call it there. Thanks again, everybody, and I'll see you next week, hopefully, with episode 344. All right. Well, take care, everyone. Bye-bye.
The joy of coding.
See ya.